Alrighty, CNT140, Chapter 9, we are continuing on with our design. Any of our outside plant cables need strength and moisture protection, strength, water, and moisture protection. Cables installed outdoors must be rated for moisture and water resistance. Many have a gel-filled cable. Some now actually have a dry water-blocked cable that actually has like a tape wrapped around the cables instead of the gel. Either way, they need to be rated for moisture protection. If I look at cables here, here's one that here's your direct bury, your with the armor and so forth in. There's your water blocking layer. Here is another one that can be installed in conduits underground. We still have our water blocking layer right there as well. Outside plant is typically fusion splice for low loss connection between those two fibers. Multi-mode fiber inside can be fusion spliced. A lot of times it's mechanically spliced, and that's usually adequate for, inside plant, if you will. Any finished splices are placed in a splice tray and placed in a splice enclosure. Inside could be patch panels. Outside would be some sort of box for moisture protection. So if we look at indoor, here is a patch panel that actually has the splice tray in here. Each one of these little lines right there is a splice. And then these would be the ports out front that I'm plugging into to make connection. If I'm dealing with outside, again, I'm using some sort of splice pedestal. The splices are coming up in here. We have protection that goes over top. And if I'm doing an underground, here's our splice enclosure here that's closed up to protect it, and then underground, and then like a water sealing utility cover is put on top of that. When you're dealing with your outside plant, a lot of times you're dealing with either splicing on factory-made pigtails, or I might need a breakout kit, and that's what we're seeing these. This is actually a kit that has, these are all little tubes that those individual fibers slide into for protection, to help them protect them from breaking and so forth. Entrance facility, your premise cabling and outside plant cabling will need to kind of coexist, and sometimes where they're even connected. So here I have, maybe outside plant cabling coming to here to connect to the cabling inside. Outside plant cabling coming here connecting to cabling inside. The premise fiber optic components are affected by several factors: the type of equipment, physical routing, building codes, etc. So our fiber optic cabling is typically going to be in wiring closets. Wiring closets, I'm connecting my two switches together, and I might have a couple desktop connections for fiber. I might have a couple connections for access points, that sort of thing. So here my switch is interconnecting the fiber to the copper out to the desktop. Here I might have a media converter that's going to convert the fiber link to copper to the desktop, if you will. The design of our plant requires basically input from various people. The IT personnel that will be working with it daily, maybe management that's dealing with the budgeting and maintenance of, like, each year we need to do this, so they're going to be looking at the budgeting for possibly, and then architects and engineers of, yes, it's safe to put it there, no, it's not safe to put it there, that sort of thing. And so all of them need to be sharing and or putting input into. Premise networks use typically multi-mode fiber, sometimes hybrid, so some single mode for future. Most of our fiber now has been, initially it was 62.5/125, your OM1. Most are now OM3 or OM4 laser optimized, and we would know by the color code of the cable what we're dealing with. Your premise cabling distribution cable, this is one we looked at earlier. This is typically going to get terminated into some sort of patch panel like here to protect the splices and terminations. And that is basically popular for future. You might only be using this many, but there's this many there ready to rock and roll that I could cable into and use. Your breakout cable, these are kind of bulky, but they do allow direct connection to the hardware. So I don't need the extra, protection of splice trays and that sort of thing. I can do direct connection. This can be convenient for industrial use. Indoor cable, we should remember, needs to be fire rated. So we need to worry about the general riser plenum, depending on where the fiber is going to be installed. Remember the labels on the outside of our jackets to know where they can be installed. So our premise cabling needs to worry about the fire codes. There is such a cable as an indoor-outdoor cable. It literally has two jackets on. The outside jacket's for moisture protection, being buried, that sort of thing. There's your armor. And then once it comes into the building, you can strip the outside jacket off and even the armor off. Now you have an inside jacket here that will allow me to bring it into equipment, terminate, and so forth. And this would be the fire-rated part of the jacket then, because this outside jacket does not need to be fire-rated. Just need to be rated for the moisture and water protection, if you will. Fiber optic connector choice. For a long time, ST and SCs were pretty popular. Most have moved on to using the LC, like we've been using in our lab and even terminating our lab this semester. So here's a quick reminder of your ST, your SC, and now here most are using the LC. This is the kind of connector we've been using, the kind of SOPs we've been using. Your fiber optic and premise cables are typically run separately, either in its own tray, sometimes hung under the cable tray where the copper cable is, or can be installed in interduct that would be hung under the tray or maybe at the edge of the tray. You just got to make sure you don't bury this under copper cabling, because the copper cabling can be pretty heavy and cause damage too. But your interduct is protecting that. Premise runs, generally point-to-point and not necessarily splice, but you do need to make sure that you have some service coils here for being able to move and terminate things or reconnect things and change things around. Every installation requires a complete materials list, hence why in our bid spec we've been trying to generate a list of all the possible equipment we might need for the job, getting a good estimate of what's going to be involved for ordering as well as cost. There should be some extra quantities included. We didn't really do too much of that in our bid spec, but typically on install you need to have a couple more of everything. We kind of rounded up on a lot of things to help with that, but on jobs sometimes they purposely engineer in 2 or 5% more to make sure there's enough for, improper terminations need to be cut off and re-terminated, and also a couple left over that the customer has that matches everything that was installed. For our fiber plant, we need to do a loss budget analysis. And this is actually, we did this in one of our last fiber labs. We did this for our bid spec fiber. So this will allow us to calculate what the loss is predicted. And then when you install it and test it, the testing should be hopefully less than the predicted. And then you have a pretty good design. The attenuation bandwidth are key. We do need to look at the losses of connections and splices and so forth, but this should be done early on. There is loss to the fiber itself, there is loss to each connector, and there is loss to each splice. So that needs to be accounted for. The idea of loss budget is to, again, work out what you expect it to be, and when we do the install, it's kind of like a worst case estimate. When you do the install, it should be less than your estimate. And they've shown you here of like, okay, calculating a loss budget. So here they have, this is the loss budget they're going to calculate. So they walk through, okay, first is the amount of loss on the fiber itself. And there's ratings on the type of fiber and what kind of loss you're going to get. So they did a couple different samples here of what you might get on a particular type of fiber. Then you calculate for each connector loss. Then we calculate for each splice loss, or the loss on each splice that you have. And then you basically add these pieces up to get your total cable plant loss. And that'll give you an idea of what your loss is. Now, we did this calculator that was available, and this kind of did a lot of this for us, which was a handy little calculator. This is what we did in one of our last labs. This is doing the exact same process that they walked you through here in those last couple slides. There is an equipment loss budget calculation that is done on the equipment itself. The data manufacturer lets you know about how much loss from the equipment that you're dealing with on each end. And then you come up with a margin. As a general rule of thumb, the link loss margin, we're talking like 3 decibels, if you will. So all of that then you would compare I think I have it there. Yeah, there. You basically compare with what you expect to what you got. And here, there typical cable plant loss 3.8, link loss margin, have about 11 decibel. So if you're predicting that's there's worst case scenario 15, but you actually have 4 or 5, you have a margin of about 11 decibels. And over time, the loss can increase over time because of age, so you want to make sure you have a bit of margin. They're saying approximately 3 for over time, as long as you have at least 3. All right, documentation now. Documentation has to be kind of part of the whole design, install, and troubleshooting, and at the end. So here they're saying, hey, it's a necessary part of the design install process. After component installation and then during troubleshooting, we need to consult that to know what we should be expecting. Proper documentation is usually required by the customer, and the customer acceptance of the install. Like, yes, everything looks like it works correctly. We can sign off on this, and this can be done. We have to actually document from the get-go, which is why on some of our stuff on our bid spec, we were making maps and charts and diagrams from the get-go. And that is things that can be added to, test results added to, and then turned over to the customer. The outside plant, we got to document everything. Where is it going? How deep it is? What side of the street? How many cables? Where each fiber is going? Where it's terminated? Where each one of those fibers is going when it breaks out? Premise cabling is a little less, but I still do need to document, like we've been doing, where all of my ports are going, my distances of things, and labeling of things, so we know how they're where we can find them, which is why here in our bid spec we documented all of our cabling. Here's our outlet boxes. We have the patch panel. We even have a spreadsheet with all the patch panel ports. So documenting where everything is going. A lot of this can be kept in CAD drawings or a database. We were doing spreadsheets, which could be converted to a database, in a larger project. We need to document the layout for the network. Okay, we're using some sort of CAD drawings and putting things on top, just like we were doing. We were taking our building map and putting information on top, and then we're using a spreadsheet to supplement that. Here, talking about the many different types of fibers, we need to know where are they going, where the path of that fiber is going, what is it interconnecting to, what is the test result, kind of the loss budget, and then what is the test result we got when we actually tested it after putting the fiber in. What types of panels, hardware being used, where is it being connected, and they even say here, have a good design idea, have some spare fibers and interconnection points or extra ports on patch panels, just like we were doing. We always had a couple ports on the patch panel. When we spec'd out the fiber between the clauses, we had a couple extra fibers that could get used at a later point in time. We could terminate and label them and just plug into them later as we need them. It's a little bit more than just records, so we need to have all the components labeled, color-coded, kind of like what we've been doing in our plan. The spreadsheet with all the patch panel labels, that is the kind of thing that should be done here. Keep backup copies. A set should be shared with a customer. The installer should be keeping a set, and then there should be a set kept with they call it a restoration kit, a box of connectors and splice hardware, those kinds of things, along with the documentation. That way that can get grabbed and used in the event of an emergency of needing to, re-terminate or bring something back online. After the design of the fiber optic project is complete and documented, it's just the beginning. So now we need to coordinate all the activities, all the people that are going to be involved. And this is developing a lot of checklists. I think they have a bunch of checklists they shared with us as well on this process. You need a main person, point of contact, project manager, and everybody needs to know who that is. And on larger jobs, they might need to be available 24/7. Sometimes maybe even at the job site when work is going on. They need to be there to be able to answer the questions or make the decisions on what should be done. On a larger job, there might need to be a backup person as well. And they might be the one doing a lot of the documentation, answering the little immediate questions, but then documenting things to answer the main project manager as well. But they could be doing part of the job. Here's where they shared a bunch of checklists with us on the process. We'll come back in the next podcast and finish these last couple pieces up.